This is section 10.1. Here's the first part of problem 3. What have we got here? The following table shows Myers-Briggs personality preferences for a random sample of 519 people in listed professions. T refers to thinking and F to feeling. Right, so we got a table here. What have we got? Occupations, clergy, MD, lawyer, and then personality types, thinking and feeling types. Use a chi-square test to determine if the listed occupations and personality preferences are independent at 0.01. So first up, what's the level of significance? I think we can't miss that one. That's 0.01. Now this part of the question asks for the null and alternate hypothesis. What we're testing here is that these occupations and these personality types are independent. Do any of these talk about independent? Well, the first one's not independent, so we can skip that one. This says Myers-Briggs preference and profession are independent. This says that they're not independent. Let's see. That looks like it could be. Myers-Briggs preference and profession are not. Forget that one. Myers-Briggs preference and profession are independent. Preference and profession are not, are independent. Okay, these are both independent. I think we have to go with this, that your profession and your preference are independent versus that they are not independent. So let's go with this one here. And then this question down here, find the value of the chi-square statistic. All right, what we're looking for is this. What is the value of that chi-square? I'll call it star. And we're going to get that using our calculator and just running a hypothesis test because it shows everything we need. To run this hypothesis test on our calculator, we're going to need to use the matrix feature. So on your calculator, here's where we'll start. We'll type in second, or we'll press the second key. And then if you look down a few keys, you'll see alpha, test, and then you'll see a matrix key. Now the matrix key is on the x to the -1 key, and right above it, it says matrix. So you press second, matrix, and because we're going to enter information, we're going to arrow over to the edit key, and what you see is 1, matrix A, 2, matrix B, and it goes all the way down to 7, at least on mine, all the way to a matrix G. So there's even more. So there's a bunch of matrices that we can put in here. We're going to use only one, and that's going to be A, or just choose any one you want. I'm going to choose number 1. All right, so I'm going to choose 1 and get matrix A. Now when I do that, what comes up is this. It says matrix A, and then it tells me a size. It says something by something. Now, you may already have numbers in there, but we're just going to type over them. What size is our matrix? Now, the size is the number of rows by the number of columns. So look back up here at our matrix. At our matrix, we have what? Well, they've colored it for us here, but we really have three rows, right? Clergy is a row, MD is a row, lawyer is a row. So we have 3 rows. The column total and occupation doesn't count. So we have 3 rows, this one, this one, this one, and 2 columns, the personality types. Totals don't count. All right, so we have a 3-row, 2-column matrix. So what we're going to type in here is 3, press enter, 2. All right, so just press 3, enter 2. Then your cursor comes down right into the matrix. Now the matrix actually looks like it's just the way the calculator draws it. But you're going to land here. You're going to have your cursor right here. So what it wants is it's expecting your first value right there, that 55. So just type in your values one at a time, pressing enter. All right, I'll do them here. So I'm going to type 55. And then when I press enter, the cursor moves over here to row 1, column 2. All right, so type in the 93. So I type in the 93. I'm doing it too as we do this. Press enter. Cursor drops down to this row here, which is an 82. So type in 82. Press enter. 77. Enter. 112. Enter. And 100. Enter. Now it may show up, but it shows up over here. All right, so we've got our matrix in. Now I'll show this up at the top, but what we're going to do is we're going to get out of that matrix editor. And we'll do that by pressing second. And then right next to the second key is a mode key. But since we're going with second, right above mode is quit. All right, so we want to quit that editor. So press second, quit. Now we're ready to run the test. So we know what to do here. We're going to go to Stat, over to Tests. Now what you have to do is you have to scroll down quite a ways. It's item C, and it says chi-square test. Now right below it, in D, we're going to use this one in the next section. It says chi-square GOF, goodness of fit test. We'll use that one in the next section, but right now we want this one here. So select C, so scroll down to C and press enter. Now it's not asking for much. It's asking for this, observed. All right, so it wants the observed matrix, and then it wants the expected, and then it's going to say calculate. Now for observed, our observations are here in matrix A, so we need to get matrix A. So how do you do it? You press the second key, and then you go to that key down here that said x to the negative 1, which is a couple keys below that. It says matrix. All right, and all your matrices come up, and we're using A, so just press number 1 or enter, right? And that should fill in matrix A. All right, so you're in observed, go to second, matrix, x to the negative 1, press number 1, and matrix A should come in. Now get your cursor right down here to expected. We're going to put our expected values into matrix B. Now the calculator does all this computation for us. You know, if you looked at the video on getting expected values and observed values, there's quite a bit of arithmetic, but the calculator does all of it. All we have to do is put in the observed values. The calculator will come up automatically with the expected values, and we're going to store those into B. So just go select matrix B. So what do? You know, you got your cursor on expected, so then you go to second, x to the negative 1, right, matrix, and just select matrix B, number 2. So you scroll down, select number 2. So matrix B pops in. Go down to calculate, press enter. And on my calculator, I'm showing this. Chi-square, it's really chi-square star. It comes out to be 9.759 and so on. And here's the p-value. That's the one that we really want here, 0.0076. I'll just round off a bit. And it also says degrees of freedom 2. All right, now I think we can fill in some of the answers to these questions. So this question over here, chi-square value. What's the chi-square value? Well, the calculator computed it for us. Round to 3 decimal places. 9.75. Oh, all right. So here's what it actually is now. Look at my calculator. It's 9.7595. If I round, all right, to 3 places, that goes up to a 10. So I get what? 9.760. So let's use that. 9.760. Now the next question says, are all the expected frequencies greater than 5? All right, we're going to have to check this. Now it's an easy thing to check, But let's do it later because we have all our information here. What we're going to have to do is just go back, pull up matrix B, and just check to see if all the expected values are greater than 5. They wouldn't be giving us this problem if they weren't. So right now, just to continue on, I'm going to say yes. We'll come back and show you how to do that. Now, what sampling distribution will you use? Well, we're using a chi-square, right? That's what we're using. We're using chi-square. And what are the degrees of freedom? Well, degrees of freedom, calculator showed us that. That's 2. So we're going to enter a 2 here. Now, you remember from the theory video that the degrees of freedom is equal to the number of rows minus 1 times the number of columns minus 1. We have 3 rows minus 1. We have 2 columns minus 1. So we get 2 times 1. There's our 2 degrees of freedom. Now, down here, the p-value. All right, so estimate the p-value. What do we get? We got 0.0076. That's about 0.76. It's not even 1%. Right? It's not even 1%. So where are we down here? Well, this is what? This is 5% to 10%. This is 2.5% to 5%. This is 1% to 2.5%. This is 0.5% to 1%. I think that's where we are, right? Because look where we are. We are at 0.007. Oh, we're still above this, right? We're still above 0.005. So we're down here. P-value is less than 0.005. That's 0.5%. We're a little bit more than 0.5%. So we're down here at the very bottom. Got a very small p-value. Here's the next 2 questions. D says, based on our answers, are we going to reject or fail to reject the null hypothesis of independence? So this is where our p gets compared to alpha. So here's p, here's alpha. Our p-value was 0.0076, I think, and alpha, all right, they ask us to use 0.01. Now, how does this compare? Well, this is 0.07, this is 0.01, this is less, right? This is about 0.7%, this is 1%. So if it's less, you reject H0, right? This is less than, so I'm thinking small, but it's a p-value, so it's a small probability. And if the probability is small or low, I think it's an unlikely event. And if it's unlikely, I'm going to reject. Now, if I reject, what is it that we're doing? You know what? Let's go back here. I'm going to go back to the previous page. I'm going to look at my H0. Here's H0. What was H0? That the preferences and profession are independent. All right, so we're rejecting this. We're going to reject that they're independent and say that they are not independent. Let's go back. Which one of these are we going to run here? Okay, well, first of all, since P is not greater than alpha, it's not greater than alpha. What about this one? It's either one of these. Since P is less than alpha, we reject the null hypothesis. Yes, that's what we're doing. And then our conclusion is, all right, make an interpretation here. Remember what we're doing? We're rejecting the independence and saying they're not independent. So at the point, at 1% level of significance, there is insufficient evidence to conclude that they are not independent. Okay, a lot of double negatives there. What does this one say? At 1%, there is sufficient evidence to conclude that preference and profession are not independent. We have enough evidence, that's why we're rejecting. Right, so we're going with this one right here.